Let's start with this. First, I want to just ask you to sign up if you haven't done that. Go to 1db.ai and sign up for an account, because you will need this to be able to run the hackathon after this. And you also will need a Kaggle account, because we will be using an in-class competition. So to submit your results, you will need a Kaggle account. So just go ahead and go that if you haven't signed up yet. The ML is transforming every industry. We see that tractors are now like detecting weeds and automatically improving the efficiency of crops. We have drug research that it's taking leaps and inventing drug agents in healthcare breakthroughs. And AI is assisting every industry that we can think about. Reinforcement learning has taken a lot of industries, like game industry, is now also in trading industries and banking. But every week or so, we hear like ML projects causing disasters and tarnishing brands and reputations. We have statistics that show that 80%, 85% of machine learning projects fail. So our practitioner is tracking the spelling in spreadsheets, and the data versioning is funky file names. We have all lived this, like a bunch of Excel files with different names, or notebooks that just get untitled notebook number 1, untitled notebook number 2. And reproducibility is always a problem. We spend a lot of money in bad training data. We get biased models because we don't explore our data correctly. We get bad models pushed to production if we cannot track correctly which models, which one is the latest one, which one was trained on what data. And the best practices are complex to be shared between practitioners. So that's where I want to discuss with you that weights and biases is a tool that tries to solve a part of these problems. And our core, our development-centric platform is Interval product. Our flagship product is the experiment tracking. As you can see in the right side, this is a pane you get in your workspace. So each line is a run, and your models get version, and everything gets tracked. And you can go back in time and see what you did, when you did it, and which parameters were put into production or for training, or whatever you did with your model. The product is collaborative, which means your team has central repository for all the experiments. This is key for reproducibility. We also have tools like hyperparameter sweeps that let you tune your parameters in an organized way. This function lets you automatically search for the most optimal parameters for a given optimization function. We also have artifacts and tables. What I'm showing you here is a table where you can see your predictions and your training data together with the models that are being computed at real time. Artifacts let you save and version your data, not only your data set, your model, your checkpoints, whatever you want to save. And tables let you engage your team in exploratory analysis. I'm going to show you later on, but this is very useful for studying your data set and getting insights that then you will be able to use in your model training. We have also a lot of collaborative insight. Our product is collaborative. Sharing is the most important part of machine learning training pipelines. So you can share with your teammates and improve your experiments and track what other people are doing in your team. We have a tool called Reports that let you embed all these beautiful graphics and data and pipe it through in these rich Power documents that have the data. I will also show you how they look like. These reports are not static. As you run more experiments, the graphics will get updated and you will get the reports up to date with the latest runs that your team had run experiments. You can usually export this as LaTeX, as a web page, as PDF. We host our full blog in this platform. Finally, you have a system that is ideal for recording all your work streams. You can complete your full project using our infrastructure or your weight and biases tools. You can manage and protect your intellectual property, and this can scale for teams like from 5 people to 500 of people. Yeah, we have clients like Toyota that use these and record every single model they train using weights and biases. Of course, we fit in your workflow. Like we can integrate in any of your favorite deep learning or traditional ML frameworks. We PyTorch, TensorFlow, and we also have a lot of repositories that have already instrumented weights and biases, like YOLO, Detectron2, Catalyst, Moz, whatever. If you find a popular repo, probably we're already in there. This is just a Python library, so it's not that hard to put your code to work with OneDB. We also run in any of your favorite cloud infrastructure, and we are working together to integrate more tightly with them, so you will get access easily with AWS, NVIDIA, Azure, Cloud. It integrates in your infrastructure also, your model training. With your server, you can run even weights and biases locally in a Docker container, and this is very useful when you don't want to share or you have sensitive data that you don't want to share with cloud providers. It's very easy to integrate. It's 1 minute and your code will be running with OneDB. It's 5 lines of code for our popular libraries. So it's an ML practitioner's tool built by practitioners and used by practitioners. So let's go with this. I'm going to put you a link here. This is a OneDB link that will open a Google Colab. And please go ahead and click on this link. Just going to check in the StreamYard. And just please open this link and you will be presented with our Google Colab. This Google Colab looks like this. We will go together and go through how to instrument a small PyTorch code with OneDB. And we will run an experiment. Well, you will have to log to Kaggle, and we will present you a competition that it's ready to you to follow. Show you the competition, and we'll open this here. I have to log in Kaggle. Let me say name. You see my entire screen? Can you see this? This is the competition. Our competition will be running the blonde meats competition. This is the dataset that has small images of blood cells. And we will run a competition on classifying different types of blood cells. So the Kaggle notebook the Google Colab notebook I push here will run to creating a model that is capable of classifying these blood cells. So let's go and run this together. I'm going to connect here. This is a pretty quick to run notebook, and you will have to tune this notebook to make it perform better. So we'll just run a baseline, and then you will be able to create a submission file and upload this to Kaggle. So the first thing you will need to do is authenticate and create. If you don't have an account within weights and biases, please go and create one. And once you have one, you will have to run this code, and it will ask you to authenticate to OneDB. So you will have to paste your token after running the line onedb.logging. Okay, so as you can see, this is just your standard PyTorch code and importing some libraries like Torch, Vision, Pandas, all the classical stuff. I'm giving some global variables to have a reasonable name to our project. We will call this blood means hackathon. As I have already logged in this computer in my OneDB account, it's already the key is already there, so I don't need to log. You'll have to copy and paste the key here if it asks you to do that. So the first thing we are going to do is just download the dataset. We're using the artifacts API that enables us to grab an artifact from that's already available in our workspace. So we are downloading the dataset. I put this to make it simpler, so you don't have to download the dataset from Kaggle. Anyway, the dataset is not available on Kaggle. There's no data here. So we will see the leaderboard filling up as we run this. So yeah, let's define some blot-mince data set. I can show you in as we run this, the outputs that are generated in our workspace. So we will define this. This is just creating the blot-mince data set, how to read these images. This like means these are NumPy arrays, so we have to put them and put them in the right format. Then we create a data loader. We will not get exactly through the details of here, but the validate function is the important part here because it's logging to 1DB. So as you can see, 1DB is just a Python library. We are creating a table. I will show you right now what a table is. And we will log these to 1DB. So we are downloading the dataset that was already available, and we are uploading that back for doing an exploratory data analysis. Here we create a run to our project name. We put a job type. This is just for organizing. So we are logging the dataset, and we will create a table with image and labels. And it's logging that table to 1DB with just 1db.log, and you pass the table, you put a name to the table, and that's finished. Once you do that, once 1DB finish a run, the run is the core. A run is just an experiment. When you finish an experiment, you get a link to that experiment. If we click that, it will open our workspace. I will have access to the run. It's taking a little time to finish here. Come on, Google, you can do better. So it's finishing the run. So you can see it finished. We can click here, and it should open the run. And as we log a table, we have here the table that we call here train data / train table, and we get this table. As you can see, the table is here. So these are the images we are trying to classify. We logged a rich table that supports images with the label. So we can see, we can scroll them. We have 1,400 images. These are small images. Huh? These are like 28 by 28, like minced. So we'll try our best to train a classifier on this. So yeah, you can use whatever network you want. I will use just a small mobile net. This is a very fast architecture. It's very good for inference because it has really low latency. So we will grab one from Team. I really like Team because it gives you a lot of pre-trained models. We'll create a new run with 1db.init. We put the project, the configs, the number of epochs, standard things for deep learning. And then we run a training loop. So we will train. And we will be logging to 1db the metrics. Like at each iteration, at each step, we will log with 1db.log. This is the only thing you need to add in reality to your code. What do you want to log? Here we want to log the metrics. These are just floats, the loss. What epoch are we at? Example count, how many images the model has seen, and logging validation metrics after validation. So this end. And we will, of course, generate a sample submission. So you get a CSV here. Submission file. We will log that to 1db also, so we can have the submission file as an artifact, and we can finish the run. Once you do that, you will get the same link as we got before. This will be a new run. So if you go here to your project, blot-mince hackathon, you can see I have already done some logs. This is the one I'm doing right now. It's active. That's why it's finishing here. So it's there. We can click that. And runs are experiments. So let me refresh this to be sure it finished. So Sweet Donkey is the last run I did. Let me hide everything. Visualize known. Let me put just the last one. So the training went fine. The training loss went down. Examples increase as we ran 3 epochs. Validation loss went down. That's good. Accuracy went up almost to 80%. And we log some predictions. So this is the model, the input file, the real label, the predictions of the model, and the scores, the logit scores for each classes. There's only 7 classes here, 7 types of plot cells. And we can do all kind of funky stuff, like panda stuff type of filtering, we can filter that if the label is different than the prediction. That's pretty useful. You are going to see where the model gets wrong. So here it's predicting 5 and it's class number 3. You can look at individual logits, and these give you insights about like what can you do to improve the models. Maybe the image are not labeled correctly. Maybe it's very hard to distinguish between two classes. And that's the powerful of 1DB tables that lets you like explore your data, explore your model predictions, and take actions on that. Okay, also you get some fancy stuff that, yeah, you get system metrics. So you can see that the GPU was used at 30%. Maybe we can do better, increase batch size to get more GPU usage. Sorry, that's the GPU power. So that's not what I want to look. I want to show you GPU utilization. This is what I'm more interested in. Like 20% is very low. I have a Colab Pro instance, so it has a better GPU than the basic Colab instances. And this is a really small model. MobileNet is very small. Maybe we can increase model sizes. So you can check the system, the memory, the CPU, the network traffic. This is very, very useful when you launch like very large trainings during the weekend and you are not present. You can also connect your training to send you alerts. In this case, they are not activated, but you can send alerts to Slack. And this is very cool. You get alerts by email or by Slack. We are integrating with more tools like Teams and maybe Twitter. I don't know. We were thinking about integrating more, but it gets you that alert that your run crashed on Saturday, so you can actually kill your compute and not pay for that the whole weekend if it's not training. Yeah, I'm missing the Kaggle link. I will put that. The Kaggle link is here. I can put that on StreamYard, maybe here. That's the Kaggle Minst competition. So once you have done this and run the notebook, you will get this CSV file that you log as an artifact. So you can go here to artifacts and see the submission file is there. You can see the latest one. So you can actually download the file if you want. Let's do that. Now, once you have done that, you can submit this to the competition. So yeah, I'm the host, so I can sandbox submission. I can test my submissions here. So I can put that here. We can see the score of this file. So it's scoring 80%. Let's make that the benchmark. And now in the leaderboard, maybe, yeah, we have a benchmark. That's my benchmark. I don't have any team or anything. So as you run this notebook, please submit your benchmarks, and you will get like a public score, and then we'll have a private score. The private score is in data that there is a 80-20 split in the data that it's hidden from you. So you have to make a model that generalize well. Let's keep this page open so we can refresh this leaderboard time to time and see how everyone goes. Some ideas you can try here. I can give you some hints. Maybe try a bigger encoder. You have access to all the encoders that are available on Team. Here I am using MobileNet. You can maybe use where I'm defining MobileNet. Let me just search for that. Is this big enough? Everyone is able to read this, or we need to make the text bigger? I can make it bigger, like a little bit bigger. So you can change this. Maybe put like, I don't know, a ResNet 50. You can go to Team, PyTorch image models, and check what models are available. Ross has a bunch of good architectures to try for you. Model summaries, it's here, like, yeah, you have all that architectures. Like, he has a very good ResNets that are very efficient. I like ResNet D. This is like a state-of-the-art ResNet trained as it should be trained on 2022. So maybe try that one. Just I'm checking. Do you have access to the Kaggle link? I can put that. I don't know where I can put that. As a comment? No. So please go ahead and send your first submissions. I will also encourage you to try to increase the number of ebooks. 3 is very low, maybe 10, maybe 20, I don't know. If you are familiar with PyTorch, maybe try some learning rate schedulers to get better use over GPU and have better convergence of your model. Yeah, this training script does not have any augmentations. Also, maybe put some augmentations in there, so you will have to modify the train data loader. So the function get data loader that's here needs some reworking to have augmentations. You can use those vision ones, augmentations, whatever you like. The class already supports transforms, so you'll have only to pass a list of functions to the dataset and it should work. And that's it. I can show you another project I did recently, so you get an idea of what are the powerful features you get from 1DB. This is something I'm not showing you yet, but you can also try that. This is hyperparametered search. Like you want to increase your accuracy, so you try a bunch of different parameters like batch sizes, loss functions, different loss functions, different values of weight decay, different backbones. That's what I'm encouraging you to do that, like MobileNet versus ResNet versus ResNet 34, 50 VGGs. And this is a multi-objective training function. So problem. So you want to increase foreground accuracy, but with also increasing dice. This is for a segmentation task. So you want to get good details on the average picture, but also finer details on every object. So you don't miss small objects, but you also classify correctly the image on average. So this is, I'm not only interested in good foreground accuracy, I'm also interested in values that get higher dice multi-coefficients. So dice is like intersection of reunion, but with some sweet computational fixes. So you can do this type of graph and these types of exploration. So all the runs, I have a bunch of runs here, like 300 runs. So you are looking at a lot of compute. And yeah, you can, tables are super rich. You can plot stuff that has segmentation masks on it, and you can filter them. And we have a segmentation mask class, so you can look at complex classes. In this case, we were looking at pedestrians. Like we don't want a model that misses pedestrians for autonomous vehicles because it's dangerous. So then you can filter and look at edge cases. This is a case like a table that's filtered to search for pedestrians. And we are looking at the worst examples, like ground truth versus prediction mask. As you can see here, the pedestrian is, yeah, it's missing that pedestrian and classifying pedestrians here and there. So this for exploratory data analysis is super useful. Traffic lights, the same. We don't want a model that misses traffic lights. And reports is something maybe you will not use today, but you can make these beautiful documents that embed these types of graphs directly. So you have the tables embedded on the document. And this is tied to the run. So experiments you can filter there. So you can see what experiments produce this table. You can, export, as I show you, data automatically. You can create these dashboards with the latest experiments, the best performing model. With this gets updated when you run more code. So it's very useful to give stakeholders a nice view of what you are doing. If you are collaborating in a team, this is very useful. My manager always loved this. Like when I used to work before joining Weight and Biases, I was already using this tool, and these types of report, like to show them what I'm doing, why I'm taking these decisions, what I'm planning to do next week are really useful, and they really like them. So I don't know if someone yet has managed to put a submission to Kaggle. I can refresh this. Not yet. So if you have any questions, please ask them on the chat. I can answer your questions. If you have questions about PyTorch or whatever deep learning you have, But this is pretty standard PyTorch code, like a dataset, data loader, training loop, and validation loop. I will leave the link here if someone is looking for the link. I can share that on StreamYard here. Yeah, how can we upload the data to 1DB? It's actually being done in the notebook. The notebook is already doing that for you. I'm just putting a skip here. Like this is the, let me check here. Yeah, we are getting the data. I uploaded already the data to 1DB. It's already there as an artifact. When you do this and download from this use artifact, you are getting the artifact that contains the data is here in this project, fully connected blood means latest. So you're getting the latest version of the data. And we are actually downloading it from 1DB and re-uploading it to 1DB. And here, this is actually uploading to 1DB. It's creating this table that you see here. Go to overview of the project here. That means hackathon. This is my project. It's under my username. Projects block means it's not a public project. And you will have the same thing. You will have your user project block means DV hackathon once you run the collab. And you will get this table. So this table is actually the data. It's the predictions data. So yeah, you can actually go to the artifacts pane and explore what you have uploaded to 1DB. So you have run tables here. You can click on the artifacts and you can see that this created, where I can search for that. Snowy fog. you have a run table here, and this is the table. It's not uploading anything here, but this is the table I was showing you here. When you go to the overview of the project, it gets automatically shown here. So I encourage you to run this completely, and you can click on the links after each one to be finished, and you can go and open the projects. I can rerun this cell if you want. This is the cell that logs the table. But as you can see, I put a break, so it's logging only 10 steps because, yeah, it can take a while. So I'm just logging the table partially. Yeah, because actually this is done in Python asynchronously, so it's not interfering in your execution of your code. It will be very slow to be logging and like waiting for the data loader to send you data. So it's caching all that, and it's logging at the end when you call finish. So there's like a delay between this run ends. So it's actually now it's probably actually uploading. So that's why it's not finishing instantly. So as you can see, it upload. It's 100 yeah, it's 1400 files, so it's a lot. And if you click, you get the run. So you get a random name for it run. So this is made with a small Python library that gets random names, so they don't collide. So you have unique names for each run. So there you go. This is the table I just uploaded. It's only 10% of the data. How can you save different models? Actually, when you execute your code, this is a very bare bone example because I rarely use pure PyTorch. As a deep learning practitioner, I prefer relying on higher level APIs, mostly PyTorch Lightning or FastAI or Keras. So in these libraries, even Hugging Face, we have callbacks that integrate everything automatically. So in these cases, if you put the callback to work with you, it will log them all automatically at the end of the training. But here, as we are using pure PyTorch as pure TensorFlow also, we are logging the module manually. So there you go. It's torch save. You are saving the model to a model file name, and then we are logging that to an artifact. So you get the model name that gets saved, and we save that as a type model. So if you go to artifacts here, let me open the full project. If you go to artifacts, there's a model category here. So the mobile net large that I recently trained, the checkpoint is saved here. So if I go to files, there is a PyTorch file. It's a 17 megabyte file. You can load that, download that. You can tag them, put notes on this. This is the trained during hackathon. So then when you come back 1 month later, you will say, oh, this was the one I loaded in the hackathon. So I don't need to. And if you want more information on this, you will go to info, and you will get access to all the epoch parameters you use during training. So this one was trained with 3 epochs. The batch size was 128. How many samples it saw, and what was the accuracy of this model, the validation loss. This is getting a complete overhaul in a couple of weeks. We are making a model registry, so we will be able to get like a table comparing all the models with all the parameters and all the metrics you are interested when you log the model. But this is pretty good already. Like you don't get lost. That's the most important part. How can you group multiple runs in a same group on 1DB platform? You have multiple options here, but ideally, I like to pass the group parameter when I want to group stuff. You can log them grouped already. Like here, when you go init, any moment you call init, a run gets created. So here, for instance, you can actually pass a group parameter to init. Like, yeah, it can take a lot of parameters, but here you could actually put group equal to, I don't know, EDA. And then each time you run this code, you will run it multiple times. You will get, all these runs will get grouped on the EDA group automatically. But you can do that afterwards also. You can go here and you can see all the runs as a table. This is, I have already run this project before today. So yeah, you can group them by I don't know, by name, but state. I use more filter than group for my usage. You could group them by architecture. I could group by Mac backbone. No, how do they call that? I don't know if I logged the model name. No, it's not logged. We could actually log by model name, and we could log all the mobile nets, all the REST nets. We could group by batch size, for instance. If I train multiple batch size, you could train by size. So it got grouped. This one probably something that failed. So these are these are runs that are not training, so they don't have the batch size parameters, and these are grouped by batch size. I don't use that much group. I use a lot of filter. Filter is very useful. Like I like to filter, for instance, for finished. Like I don't want to see runs that crashed. Sometimes I filter runs that are running some cloud provider and not the other one. I can filter by architectures, by models, by batch size, by different parameters I want to filter on depending on my task. Let's check if someone already managed to get some submissions. Not yet. I don't know if you are all new to Kaggle. Yeah, but you need to submit and go to this competition site. Once you go to the competition site, that's the address. I will repaste that here in case it's missing. You will have to go here to you can go to the leaderboard directly, and you can call my submissions and submit. So that's it. I cannot do it because I'm an organizer. No, I cannot do it. I can only submit benchmarks as I did before, like in sandbox submissions. Oh, it's not. Oh, sorry, my bad. It's not activated yet. Like now, you should be able to submit predictions. No, that was my bad. It's not. It's not. It's now activated. You can submit now. Yeah, I can also submit. Let me submit what I just created. This is the CSV I downloaded from 1DB. Yeah, now it's submitted. So we have to go to the leaderboard. Here's my submission. It's the same as before. So no, that was my bad. I was not. The competition was blocked. Now it should go. It should do. Just take your CSV files that you just downloaded and submit predictions. Another option is in Google Colab. You can have access to the files that this is not the Google Colab I was running. This is another version of the same thing. If you go here, you can go and see the files that are created in this virtual machine. So the CSV file is also there. You can download it here. Download. Is the link working right now? This is my first time organizing this, so there's so much set up on this, but it should be working now. This is public now. It's running. So this site is should be able to go there, and it should be open. Let me check on my web and on my mobile phone just to be sure I have access to the link. Kaggle recently changed because we were using something called in-class competitions, and it's not there anymore. It changed like last week, so I don't know exactly how this behaves compared to. Yeah, it's actually live. Like I can access this from my phone. That means competition without any logging to Kaggle. I can actually see the competition. So just go ahead and get this file. Just run the notebook with the default parameters and send the submission CSV, so you get a submission up there. Or you can straight away change some of these parameters, maybe put 10 there, decrease a little bit the learning rate. And also, yeah, these flags logs the images. Maybe you can disable this while you are training, so you don't log the images each time you run something new right now. So just to be clear, this is a competition that we're gonna send you some prizes if you win. So you have to send an email to events@1db.com with if you get in the leaderboard, we'll send swags to the first guys in the leaderboard. So we can check here if someone has managed to make a submission. Not yet. Just hit submit predictions and upload your file. I can show you again if you want. I think I have a submission file here. Submission.csv. I can put a note here, model 2. Yeah, it's the same as before, so it's not very interesting. Yeah, classical Kaggle competitions have the data in the Kaggle competition, but it was easier for us to just put it as a 1DB artifact, so you can straight away download it and start working, instead of like the pain of setting up the competition and downloading the data, formatting incorrectly. Let's try another architecture just to have fun in our side. Let's replace MobileNet by something fancier. And put here a RESTnet. Let's train for 10 epochs. So as you can see, it's downloading a pre-trained model, so you don't start from scratch. It's creating a 1DB run, and it's training now. As you can see, it's training. You get nice TQDM progress bars. Everyone loves progress bars. We can wait for that. If anyone has any questions, go ahead. This is training. Getting already better accuracy than before, almost 95%. So this is a basic model, like basic ResNet 34. It's not even like a fancy ResNet 34. So I encourage you to try more fancier models with some data augmentations, like just flipping the images, rotating them a little bit, changing the colors. That should do. So 90%, it's finishing there. Training is done. As you can see, you get an artifact there. That's the model checkpoint. So if you go here now and go to artifacts, models, we'll refresh this because it takes some time. It's not that there yet. It will get logged. Let me compute the predictions right now and name these submission 34 so we don't get the same name. Like that. So we got that. Let's call finish because the model hasn't been, the run is still open. That's why the checkpoint is not there yet. Now it's taking a little bit of time. It has to upload like a couple of megabytes of data. So now you see here the resident 34 checkpoint is already there. You can get the file if you need to put them all on production. It's way larger than the model line. The model line is a very good model, like fast and accurate. So if you go to your workspace in the overview here, you will see that now you have, let me activate some of them. Yeah, we have a lot of training losses. This last ran for 10 ebooks, so we have way more steps. And the accuracy is way higher, like up to 90%. So maybe we should use early stopping because we lost a little bit of accuracy at the end. Let's get this file. I will load it from here. We can submit this one. You will have to beat me because I'm also logging the data. So I can submit here. We'll put a description, so then I can resnet 34, make submission. I don't understand why the leaderboard is not updating here. There are my submissions. Yeah, you can see I started with that one, then I submit model 2, 80%. And I can see the leaderboard. But I don't really know why this is not updating. Do you guys see a leaderboard with more data than me, or just me that sees this? Just curious. Leaderboard. This is not available yet. It's just Safari that's being done.
Hello. Hi,
Hello,
Thomas.
how
Hi,
are you?
Danish. I'm fine. What about you?
Good, thanks.
Thank you for conducting such a wonderful session, first of all.
Thanks.
So
I try to
we
do
have
my
like,
best.
yeah, you actually done your best. Thank you so much. I wanted to ask, like, are you waiting for any submissions because people over here are trying to submit their best? So is it possible for you to like, I with that we can like end this session, and the people will submit their best solution in a meantime.
Yeah, I would have liked to see some of the submissions coming in, but they are not coming in. I don't know why. Like,
Actually, the students are actually new to the 1B, and actually they are trying their best to go through it. So that's why
okay,
the yeah, that's why it's taking a little while.
can you try to submit just this submission file?
Sure, I can like try to submit a demo file for you. Give me a
Okay,
minute.
but I can put a deadline on this because yeah, I will send some swag to the people. The thing I would
Yeah,
have
yeah,
loved is like taking a screenshot of the leaderboard so we know who got the first place. But yeah, it's
yeah, sure, sure.
maybe it
Uh,
was too fast or too
yeah,
rushed.
yeah, I got your point. I got your point.
We can wait. We have yet a couple of minutes.
So will it be okay with you if we like end this session and the students can like submit their
Yeah,
solutions on?
I will let the competition open. It's going to be open up to tomorrow. So
Okay.
yeah, people can submit
So
up to.
so what will be the like proper deadline time for the submission?
Yeah, the competition has a deadline already. Like it's ending in a
It's a
day.
day.
So
Okay, okay,
so people have
okay.
yet
Cool,
time to
cool,
try to
cool, cool.
submit something.
Okay, so as soon as some students face any issues, I will like mail you if I get any issues. So
Okay,
if, yeah. So thank you so much again, Thomas, for conducting such a wonderful session.
thank you very much. See you next time.
Sure, sure. Thank you.